Hello friends, our day usually starts with the sound of an alarm clock. Whether you are using a traditional alarm clock, a digital clock, or the one on your mobile phone, batteries power all this. Battery powered include portable blood monitors, hearing aids, digital thermometers, smoke detectors, air purifiers, digital door locks, etc. Now today we are going to focus on the batteries which we are using in our daily life. Without battery, we can't imagine our life. Prior discussing the different type of batteries, we must know the difference between the electrochemical and the electrolytic cell, because definitely this will help you in understanding what exactly the battery is and how they works. So let us see the difference between the electrochemical and the electrolytic cell. As far as electrochemical cells are concerned, they convert the chemical energy into the electrical energy, whereas the electrolytic cell converts electrical energy into chemical energy. In electrochemical cell, the redox reactions are spontaneous, whereas in electrolytic cell, the redox reactions are non-spontaneous. In electrochemical cell, the chemical changes occurring in two beakers are different, whereas in electrolytic cell, the only one chemical compound undergoes decomposition. The major difference in between the electrochemical and the electrolytic cell is that the anode is negative in electrochemical cell where the oxidation occurs, and in electrolytic cell the anode is positive where the oxidation occurs. In electrochemical cell, the cathode is the positively charged electrode, and in electrolytic cell the cathode is negatively charged electrodes. Though the signs are different in both the cells, but reduction always occurs at the cathode. Okay, let us see what exactly the battery is now. Actually, this battery is the electrochemical device in which the chemical energy is converted into the electrical energy, as I said earlier. Batteries are the collection of one or more cells, and all these batteries are made up of the three basic components, such as number 1 is an anode, number 2 is a cathode, and number 3 is a separator. As I told you that anode is a negatively charged electrode where the oxidation takes place. We know that oxidation is nothing but it is the loss of electron. At cathode, the reduction takes place where the electrons are being gained, and it is the positively charged electrode. And the third one is the separator, which separates the cathode and anode. In between cathode and anode, the electrolyte is being used. As far as the classification of batteries is concerned, it is of three types. There are three different types of the batteries. The first one is the primary battery, which is also known as the primary cells. Second one is the secondary battery, which is also known as the secondary cell. And the third one is flow battery, which is also known as the fuel cell. Let us focus on these batteries one by one here. As far as the primary batteries are concerned, in which the cell reaction is not reversible. Once it is happen, the chemical reaction is happen. Once the chemical reaction is happen in the forward direction, it will not get reversed. When the reactants are converted to the products, no more electricity is produced and battery become dead. The well-known example of the primary batteries are the zinc carbon, alkaline battery, etc. The second type of battery is the secondary battery, in which the cell reactions are reversed by passing the direct electric current in opposite direction. The well-known example of the secondary batteries are the lead acid battery, which is also known as the lead acid storage battery, nickel cadmium battery, etc. And the third one is the flow battery or the fuel cell. The fuel cell is the cell in which materials pass through the battery, which is simply an electrochemical cell, and converts chemical energy into electrical energy. Let us see the difference between the primary batteries and the secondary batteries. Already we have studied what exactly the primary battery is and the secondary batteries. Let us see the difference between these two now. As far as the primary batteries are concerned, in primary batteries the cell reactions are it is irreversible, whereas in secondary batteries the cell reaction is reversible. Primary batteries, once it is used, can be discarded, whereas the secondary batteries can be recharged and reused. Primary batteries have a relatively short shelf life, whereas the secondary battery have long shelf life. It functions, primary batteries functions as galvanic cell only. Secondary batteries, as far as the secondary batteries are concerned, they functions both galvanic cell as well as the electrolytic cell. Galvanic cell is also known as the electrochemical cell or the voltaic cell, you might be knowing. As far as the primary batteries are concerned, they can be used as storage devices, but the secondary batteries can be used as storage devices. And already I have given the examples of these two now here. The well-known example of the battery is the dry cell, which is also known as the Lect cell, whereas the example of the secondary batteries are the lead acid cell or lead acid storage battery, nickel cadmium battery, lithium manganese dioxide battery, etc. Prior discussing the working properties and the applications of the different type of batteries, we must have knowledge about the discharging and the charging of battery. How the battery discharges, how it getting charged when an electric current is applied. Let us see first now discharging. In discharging, a cell is a battery that is packed with the active materials at anode and cathode. As soon as the anode and cathode are connected to the load, the redox reactions occurs spontaneously. The electrons liberate at anode and flows to the cathode through the external wire and take part in the reduction reaction. This process in which the spontaneous redox reaction occurs is called discharging. And you please keep it in mind that during discharging, battery acts as the electrochemical cell, where the anode will be the negative and the cathode will be the positive. Now let us see how battery getting charged when an electric current is applied, when an electric potential is applied. During the discharging process, the active materials are converted into inactive material. Once the active material is consumed, the cell becomes inactive or dead. In case of secondary cells or the batteries, the cell reaction is reversed if the external current is passed in the reverse direction. And this process of conversion of an inactive material back into active material in a cell is called charging. During charging, battery acts as the electrolytic cell, means the anode will be the positive and the cathode will be the negative. Now we are going to study the different types of the primary batteries one by one here. Let us see. The first one is the dry cell, which is also known as the zinc dry cell or the Leclanche cell. In dry cell or the Leclanche cell, the anode is, the zinc container acts as the anode, which will be the negatively charged pole where the oxidation will occur, whereas the graphite rod will act as the positively charged pole or the electrode where the reduction occurs. And here the mixture of powdered carbon and manganese dioxide is being placed in between the cathode and anode by using the separator. Let us see the diagram of the Leclanche cell now. So this is the diagram of the dry cell or the Leclanche cell. Actually, this is the positive side or positive pole of the Leclanche cell, and this is the negative pole of the dry cell or the Leclanche cell. As I told you that graphite rod acts as the cathode, zinc container acts as the anode, whereas the paste of ammonium chloride and zinc chloride acts as the electrolyte, which is being separated by the separator. Now let us focus on the anode and the cathode reactions. The anode half cell reaction is occur like this, that is zinc gives rise to Zn2 plus 2 electrons. At cathode, what happens here? The manganese dioxide, which is present in the electrolyte, take up the electrons in the presence of the water to form the manganese trioxide along with the formation of hydroxyl ions. However, the acid-base reaction between OH minus and NH plus ions, which are derived from the ammonium chloride, evolves the ammonia gas, which disrupts the current flow. So here NH plus ions reacts with the OH minus ions to form the ammonia gas along with the formation of water, and this is prevented by a reaction of the ammonia gas with the Zn2 plus, which is derived from the zinc chloride, to form the complex ion zinc ammonium dichloride. Hence the reaction at 2 electrodes are. So this would be the anodic reaction and this would be the cathodic reaction. So as I told you that at anode oxidation occurs, the reaction is takes place like this, that is zinc gives rise to zinc 2 plus 2 electrons. At cathode, the manganese dioxide take up the electrons in the presence of the NH4 plus and the Cl minus ions to form the zinc ammonium dichloride. the net reaction will be like this. Zn will gives rise to, zinc, solid zinc will get react with the ammonium plus ion, NH4 plus ion and Cl minus ions in the presence of the manganese dioxide to form the manganese trioxide, along with the formation of the complex ion such as zinc ammonium chloride. Here water is also formed along with the formation of these two. Okay, let us see the properties and the applications of the dry cell. As far as the properties are concerned, the dry cell is very cheap and it gives the voltage of 1.5. Generally the dry cells, all of us know that the dry cells are used in the flashlights, transistors, radios, tape recorders, etc. Now just we had a discussion about the dry cell or the Lect cell. We have seen how it works, what are their applications. Now we are going to focus on the one more dry cell which is very important, which is being used in our daily life, that is the alkaline battery. Then the question is, what is the difference between the alkaline battery and the dry cell? Actually, alkaline battery functions just similar to that of the dry cell or the Lect cell. Only the difference is that in dry cell the ammonium chloride is used along with the KOH. Actually alkaline battery is an improved form of dry cell in which the ammonium chloride is replaced by KOH as an electrolyte. The anodic reaction which occurs in alkaline battery is like this, that is zinc reacts with the OH minus ions to form the zinc hydroxide, liberates the electrons. At cathode, what happens here? The manganese dioxide which is present in the paste take up the electrons which are liberated at the anode in the presence of water to form the manganese trioxide along with the formation of the OH minus ions, and the net reaction will be like this, that is solid zinc will get react with the manganese dioxide in the presence of water to form the zinc hydroxide and the manganese trioxide. The alkaline battery is advantageous over the dry battery, and the main advantages of alkaline battery over the dry battery are: number one is zinc does not dissolve in basic medium, as we are not using the base in the alkaline battery. Is it correct? No. So what I want to tell you now here, in alkaline battery ammonium chloride is replaced by the KOH, and that is the major difference. Though we are using the KOH, but zinc does not dissolve in basic medium. Number two is the alkaline battery maintains the better voltage. Number three is the life of alkaline battery is longer since no corrosion of zinc takes place, though the KOH is used as an electrolyte. And as far as the applications of the alkaline battery are concerned, it is used in camera exposure controls, calculators, watches, etc. Now let us have a discussion about the mercury battery which is also known as the mercury cell, which is also known as the mercury oxide battery. This is also a primary battery. This is also a primary cell. As it is a primary cell, you can say that it is non-rechargeable electrochemical battery, because no chemical reactions are reversed, though the electrical current, external current is applied. So as I told that it is a type of primary battery, which is also known as the Rubin-Mallory cell. In mercury battery, the anode is the zinc amalgamated zinc powder. Then here paste of mercury oxide with graphite is used as the cathode, and the paste of zinc oxide along with the KOH is used as an electrolyte. So this is the Rubin-Mallory cell, or this is the mercury oxide battery. If we look at this diagram, then you will find that here, see, this is the outer steel case, means yes, Rubin cell, Mallory cell is made up of the steel. This is the outer part of the mercury oxide battery. This is the outer top, which is also made up of from the steel. Then this is the inner part of the Rubin-Mallory cell. Actually it is tin plated top. Then this is the insulating gasket, which is used in between the outer steel case and the outer steel top. And this is the zinc powder, which acts as the anode. Here the mercury oxide mixed with the graphite, which acts as the cathode. So this is the cathode now. This is cathode, this is anode. And in between these two, the electrolyte is placed, in which the KOH, saturated KOH, is used along with the zinc oxide. So here the construction of the mercury oxide cell is very simple, though the diagram looks very complicated, but it's very simple now. So this is anode, this is cathode, and these two are being separated by, in between these two the electrolyte is being placed, and these two are being separated by the separator. So this is one more diagram. The diagram is same here, but it gives a clear-cut idea about the cathode and anode. See here, this is the cathode, this is the anode. The cathode and anode are being separated by the separator, the yellow colored layer, which acts as the separator here. The red color part of this cell acts as the anode, and this blue colored part of this cell acts as the cathode, and this is the anode cap. So as I discussed, as I told you earlier, that anodic reaction would be the oxidation reaction where the electrons are liberated. Cathode is the reduction reaction where the electrons are being gained, and this would be the net reaction. Let us see the properties of the mercury battery. As far as the mercury battery is concerned, it gives the potential of 3.5 volt. It is compact in size. It gives constant potential throughout its lifetime. It shows good performance at high temperatures and has high cost because of the mercury oxide. As far as the applications are concerned, it is used in the heart pacemakers. It is also used in hearing aids, as the small size is very small. It also used in light meters, digital watches, microphones and cameras.